MS Ramaya University of Applied Sciences.
Hi students, today we are going to see about assay of calcium gluconate. Aim to find the percentage purity of given sample of calcium gluconate by performing complexometric titration. Apparatus required for this experiment are burette, pipette, burette stand, volumetric flask, funnel and digital balance. Chemicals required are calcium gluconate, magnesium sulfate, zinc chloride, solochrome black tea. Principle: assay of calcium gluconate is based on direct complexometric titration. The complexing agent used is disodium acetate and the buffer used is ammonium chloride to maintain pH 10. Indicator used is solochrome black tea. A small quantity of magnesium sulfate is added to increase the sharpness of the endpoint. At first, a little of calcium indicator complex is formed, which is violet in color, but then magnesium indicator complex is formed as it is more stable than calcium indicator complex at pH 10, and the solution becomes red in color due to magnesium indicator complex, and then it is titrated with a standard solution of EDTA. First, calcium EDTA complex is formed as it is more stable complex at pH 10. Once calcium ions gets over, magnesium EDTA complexes are formed. At last, when no free magnesium are present, a slight excess of EDTA added decomposes magnesium indicator complex to liberate free indicator and magnesium ions complex with EDTA. Now the color of the solution is blue due to free indicator. Endpoint is red to blue. Since calcium ions are not involved in the color change, so the endpoint is due to the conversion of magnesium indicator complex to liberate free indicator. Thus magnesium increases the sharpness of the endpoint. Experimental procedure: standardization of 0.05 molar disodium acetate. Pipette out 10 ml of 0.05 molar zinc chloride solution into a conical flask. Add 10 ml of ammonium chloride buffer solution. Add a pinch of solochrome black tea indicator. Titrate with disodium acetate solution. The endpoint is red to blue. Repeat the titration until the concordant readings are obtained. Assay of calcium gluconate. Weigh accurately 0.5 grams of calcium gluconate into a conical flask and dissolve in 50 ml of warm distilled water. Cool and then add 5 ml of 0.05 molar magnesium sulfate solution followed by 10 ml of ammonium chloride buffer solution and a pinch of indicator. Titrate against standardized disodium acetate solution. Endpoint is red to blue. Repeat the titration until concordant readings are obtained. Blank titration. Take 5 ml of 0.05 molar magnesium sulfate solution into a conical flask. Then add 10 ml of ammonium chloride buffer solution and a pinch of solochrome black tea indicator. Titrate it against standardized disodium acetate. Repeat the titration until concordant readings are obtained. IP factor: 1 ml of 0.05 molar disodium acetate is equivalent to 0.021518 grams of calcium gluconate. So the titer values we have obtained, it is tabulated for standardization, for assay and then blank titration. Molarity of disodium acetate is calculated using VnN1 equal to V2N2 formula, and then the percentage purity of calcium gluconate is obtained by using the formula IP factor multiplied by assay titer value multiplied by actual normality of the titrant multiplied by volume made up divided by volume taken multiplied by expected normality of the titrant. So we will get the percentage purity of given sample of calcium gluconate.
Hi students, name of the experiment assay of calcium gluconate. Aim to determine the percentage purity of given sample of calcium gluconate. Chemicals required for this experiment are calcium gluconate, and this is the sample we have to determine percentage purity. 0.05 molar disodium editate, and this is the titrant used for determining the percentage purity of calcium gluconate. 0.05 molar magnesium sulfate added to increase the sharpness of the endpoint in the assay of calcium gluconate. 0.05 molar zinc chloride solution, which is used for the standardization of 0.05 molar disodium editate. Ammonia ammonium chloride buffer solution, which is used to maintain the pH 10. Solochrome black tea indicator used as the indicator. Distilled water for making up the solution. Components required for this experiment are spatula, butter paper, tripod stand, Bunsen burner, wire gas, measuring cylinder 10 ml, measuring cylinder 50 ml, conical flask 250 ml, 2 burette stand, burette 50 ml graduated, bulb pipette 10 ml, and digital balance. Let us start the experiment. First one is standardization of 0.05 molar disodium editate solution. For that we have to fill the burette with the titrant 0.05 molar disodium editate. First, disodium editate, this is the titrant used. This has to be filled in the burette. Fill up to 50 ml. For colorless solution, lower meniscus is to be considered. After filling the burette with titrant 0.05 molar disodium editate, pipette out 10 ml of 0.05 molar zinc chloride solution. Transfer 10 ml of zinc chloride solution into 250 ml conical flask. Fill the solution up to the mark. Transfer into conical flask. After adding zinc chloride solution, 10 ml of ammonia ammonium chloride buffer solution is transferred into conical flask using measuring cylinder. Ten ml of ammonia ammonium chloride buffer solution is transferred into 250 ml conical flask. After adding ammonia ammonium chloride buffer solution, add a pinch of solochrome black tea indicator. Stir the contents of the solution and this solution will appear as red color. After that, we have to titrate with 0.05 molar disodium editate solution. the solution changes to blue color. Endpoint is the appearance of blue color. First time the reading obtained is 7.3. Repeat the titration to get concordant values. Pipette out 0.05 molar zinc chloride solution into conical flask. Fill the solution up to the mark. Transfer into conical flask. To this, add 10 ml of ammonium chloride buffer solution. Transfer into conical flask. Stir the contents of the solution. Then add a pinch of solochrome black tea indicator. The solution will appear as red color. Then titrate again with 0.05 molar disodium editate solution. Endpoint is the appearance of blue color. Second time the reading obtained is 7.3. We have got concordant values. This completes the standardization of 0.05 molar disodium editate, and then we can start assay of calcium gluconate. First, fill the burette with 0.05 molar disodium editate solution up to the mark. Take a butter paper, fold on the sides. Weigh 0.5 grams of calcium gluconate. Tare the butter paper weight to 0. Then add calcium gluconate. .5 grams of calcium gluconate is weighed. Transfer to conical flask. Using funnel. After adding 0.5 grams of calcium gluconate into conical flask, add 50 ml of distilled water. Calcium gluconate is not readily soluble in water, so warm the solution. Switch on the Bunsen burner. Warm the solution. Solution completely dissolves, and then cool the solution to room temperature. After cooling the calcium gluconate solution, add 5 ml of 0.05 molar magnesium sulfate. After adding 0.05 molar magnesium sulfate solution, add 10 ml of ammonium chloride buffer. Transfer into the conical flask. Now add pinch of solochrome black tea indicator into the conical flask. The solution appears red color. Titrate with 0.05 molar disodium editate solution. Endpoint is the appearance of blue color. The obtained reading is 31.1. This completes the assay of calcium gluconate. Now we can do blank titration for the magnesium sulfate solution. First, fill the burette with 0.05 molar disodium editate solution up to the mark. Then add 0.05 molar magnesium sulfate solution using pipette. Transfer 5 ml of magnesium sulfate solution into the conical flask. Now add 10 ml of ammonium chloride buffer solution. To the solution, add pinch of solochrome black tea indicator. Stir the contents of the solution. The solution will appear red in color. Then titrate with 0.05 molar disodium editate solution. The solution appears blue in color. The endpoint is the appearance of blue color. The reading obtained is 6.6 ml. This completes the experiment.